Okay, biologists, welcome to week 2 of online learning. We are going to continue our adventures into, if my marker works, genetics. Okay, you will have some work that will be posted again to Google Classroom that will be due on Friday. I would recommend that as soon as you watch this video and go through the practice problems with me, that you start working on it. Because what you can do then is, when we have class on Wednesday, you can ask me questions. Because I don't mind answering questions about an assignment before it's due, but you know me, I don't usually answer questions on the day that the assignment is due, or sometimes even the night before, because I think that that's too late and you're kind of on your own at that part. So do your work early, come with questions, and we'll try and solve the problems in a timely manner. Okay, so we started talking about the work of Mendel and a few things that we need to remember. So when we have a gene, right, there are kind of 2 copies or flavors of any gene, and these were called alleles. You get one allele from mom, and you get one from dad. That's the easiest way to go through it. Okay? Now, these flavors of the alleles, they can either be in a dominant flavor, and for that we use a capital letter to indicate that it's dominant, or they can be recessive. So, and then we use a lowercase letter, okay, to show. Okay, so hopefully we remember that vocabulary. One other piece of good vocabulary that we can remember is the word genotype. And a genotype is, what the gene actually is. So say we have some sort of gene, it could be AA like this, or it could be AA like this, or we know it could be AA like this. These are what the genotypes are. These are what the actual genes are. This is contrasted to what the phenotype is. And this is what the genes look like. So say whether it gives you brown eyes or blue eyes, whether it makes a plant short or tall, whether it gives the plant round seeds or wrinkled seeds, those are what the phenotypes are. So they can be things like tall or short or round or wrinkled. This is what it actually looks like. And there's a difference between the genotype and the phenotype. Okay? The other important piece of vocabulary that we need to review is the difference between homozygous. So homozygous means that the alleles are the same. They're both the same. So you can either have 2 capital letters like this, and in this case we refer to this as being homozygous dominant, because we have two that are the same, so it's homozygous, and they're 2 dominant traits. So homozygous dominant, or we can have what's called heterozygous. And this, there's only one, there's another case for homozygous that we can have where it's homozygous like this, and that we have the 2 recessive traits, and this is homozygous recessive. If we want to see whatever the recessive trait is, then it has to be homozygous recessive. Okay? Our heterozygous means it's a mixture. It's a mixture, or as we learned, the word for that is it's a kind of hybrid case in which you have maybe a capital letter and a small one like this. Okay? This means that the dominant trait will still show up in the phenotype, but this is what the genotype actually looks like. Okay? One more piece of vocabulary before we go forward is the Punnet square. Okay? This gives us a square, as the word says, to solve genetics problems. So in many cases, we need to make this square to be able to, helps if you can actually read. We need to make the square to be able to solve the problem. So what is it? We looked at it last week, but let's look at it again. Okay, we've got a square. And for most of the cases that we'll be dealing with, we've got 4 boxes. Okay. Now on the top, we're going to put dad's alleles. Okay, so let's say whatever dad's alleles are. Let's just keep it the same. We don't need to say what it is. We'll just use the letters. So we'll say that dad has A, 2 capital letters for whatever that is, whether it's blood type, whether it's eye color or height, whatever. And on the other side, we're going to put mom's 2 alleles. Say mom is like this and like this. We're going to put them down here like this. Each letter here, for dad's one, of course, this represents the allele that goes into a gamete. So this represents the allele that's going into dad's sperm, and then this one here, right, represents mom's gamete, the one that goes into the egg, right? So you get one of these alleles from mom, you get one of them from dad. And so the child for this particular gene, we combine them together, has AA, this one AA, this one AA, A little a, and this one AA. So we can then talk about things like what is the genotype ratio. Well, for this one, it's like 75% or 3-to-1. Homozygous dominant to one that's kind of heterozygous, we could do that. This one is the genotype, so we've got this one, it's kind of 3-to-1. But then we can also talk about the phenotype ratio. And this phenotype ratio, if we think about whatever this trait is, the dominant part of this trait is going to be expressed because they've got capital letters dominant in all of them. So whatever the phenotype is here, it's 100% going to be expressed from the dominant trait. Okay, that's that percentage. Okay, if you're uncertain about some of these beginning key ideas, please, you can always pause, go back, turn on the captions, and watch some of these foundational ideas so that you've got a better chance of solving some of these questions. Okay, if you're okay with this and you don't need to go backwards, we're going to start looking at a couple of practice problems. Okay, well, that's problem number 2. It's hard to get it in here. Okay, in seals, the gene for length of whiskers has 2 alleles. Okay, so it's made up of one trait, one gene. The dominant allele, I should really push this, this is going to be a big capital W, codes for long whiskers. Okay, so already we expect more seals to have longer whiskers than shorter whiskers. And the recessive allele, small w, codes for short whiskers. Okay, so what percentage of offspring would be expected to have short whiskers? So that's what we want to know, how many are going to have short, from the cross of 2 long whiskered seals. One that is homozygous dominant and one that is heterozygous. Okay, So we want to know how many can have short whiskers. So you do enough of these problems, you can just see what the answer is without going through them. But since we're all new at this, step one, we're going to draw the Punnet square. Okay. Okay, so I'm going to put dads at the top. Doesn't have to be dad. There, it could be reversed, and mom on the bottom. Okay, so we've got one that is homozygous dominant. So what does that mean? So for example, if we say dad is homozygous dominant, that means that dad has 2 capital letters. Dad has long whiskers, and he's got 2 that are both like this. Okay, he's got 2 of the dominant traits. They're homozygous, so it's the same. So I'm really going to exaggerate this to make it a big W, because even sometimes I make a mistake, because a big W, a capital W, and a lowercase w can look somewhat very similar sometimes. And one that is heterozygous. So heterozygous, so for mom would mean that we've got the capital W, okay? You always start with the capital letter by convention first, and a little case letter like this. Okay, so we're going to put it here. And we're going to run this Punnet square to see the 4 possibilities of offspring that can be produced. And then we want to know what percentage is going to have short whiskers. Okay, so this one here, when this sperm meets this egg, it's going to have capital W, capital W. This one, capital W, capital W. This one, capital W, little w. Try and exaggerate that. Also, it helps me mark your questions if you exaggerate it. Capital W, little w. Okay, so by convention, the little w goes second. Okay, so how many of these have short whiskers? Well, they all have the dominant trait, so that means that none of them have short whiskers. So it says what percentage? So 0% of offspring, in this case, would have, oh, you can't see what I'm writing. 0% of offspring would have short whiskers. Okay? B, what does B say? B says if one parent is pure, we'll go back to what this means in a minute, pure, long whiskered, and the other is short whiskered, what percentage would have short whiskers? Okay, so pure, long whiskered. The word pure here simply means, it's a tricky kind of code word here for it, saying that it's going to be homozygous dominant is how you should interpret that meaning. Okay, homozygous dominant. So one is homozygous dominant for long whiskers, so that's going to be like this with 2 capital W's, and the other one is short whiskered. So hopefully you know what the genetics has to be. We'll draw another Punnet squared. We want to know the percentage of short whiskers. So again, we'll say maybe dad is this kind of pure homozygous dominant. So capital W, and then mom is a short whiskered seal. Now the only short whiskers are recessive traits. That's what our question says. Way back. Short whiskers are recessive. So the only way you can be short whiskered is if you have 2 of the recessive traits. So it must be little w, little w. Okay, so let's plug these into our Punnet square. So dad at the top, big W, mom at the side, little w, and I hope before we even start this, you can see what the answer will be. But let's go through it anyways. Okay, so in this case, big W, little w, big W, little w, big W, little w, We still always put the dominant trait goes first, and then this one, big W, little w. Okay? So what percentage has short whiskers? Well, in this case, again, 0% has short whiskers. Why? Because we don't have two recessive traits that line up. Now, on Wednesday, we'll talk about Mendel's experiments, and we'll talk about what's called if we breed what's called the first filial generation. We start breeding two first filial generations together, and we'll see how traits can change through different generations. But at least for this, I hope this makes sense that for B, again, 0% of offspring would have short whiskers. So I hope some of you are thinking to yourself that, well, if this is the case, then how do we get offspring? How do we get children, or how do we get baby seals in this case? How can they actually have short whiskers? What kind of combination of alleles can give us short whiskers? Well, we know one case would be if both mother and father had short whiskers and they bred together, then their offspring would, hope you could see it, would 100% have a chance of having short whiskers. But there's another situation too that would guarantee us, albeit a small percentage, of short whiskers as well. And that's what we'll talk about on Wednesday. Okay, I have one more problem for us to go through. You have a couple of problems on Google Classroom. Okay. This one, hypothetical monster from this song. In purple people eaters. These sounds like zombies that are purple. In purple people eaters. Say that quickly. Purple people eaters. Purple people eaters. One horn is dominant and no horns is recessive. So these are monsters, zombies that have horns. Okay? So it seems like most of them will have at least one horn because that's dominant. It says draw a Punnet square showing the cross. That's where we're breeding two purple people eaters together. I can't even say it. The cross of a purple people eater that is a hybrid for horns and with a purple people eater that does not have horns. So first we just need to come up with what our terminology is here. So for horns, so we're going to use H for horns. That makes sense. So HH, if it's this case, this one is going to be homozygous dominant, and it's going to have horns, one horn. This one, capital H, small h. This is heterozygous, but it's still dominant. So this case will have horns as well, because horns is dominant. The recessive case will be HH, and this one will have no horns. Okay? You can use whatever letters you want, just as long as it's clear with what you're doing. And sometimes using the same letter just helps to keep it clearer. Okay? So we're going to do a Punnet square, it said. We're going to do our square. Okay? So we're going to say Dad. We want a cross of a purple eater that is hybrid for horns. So in these three cases, which one is going to be a hybrid? This one, heterozygous, is the same one for hybrid. So Dad is going to have H like this, and then Mom, of course this is arbitrary, the two could be reversed, it doesn't matter. Purple eater for horns with a purple eater that does not have horns. Okay, so the one that doesn't have horns is two H's like this. Okay, and then what we're going to have to do at the end is summarize the genotypes and phenotypes of the offspring. Okay, so Dad H like this, Mom H H. And I hope we can see what's going to be different about this situation. So in this case, H, capital H, little h. In this case, little h, little h. In this case, capital H, little h, and then little h, little h. Okay, so these are the cases. So in some ways, because we always kind of care about what these things actually look like, so I tend to want to think about phenotypes rather than genotypes, because we want to care about what things sometimes look like. Although we shouldn't. We should care what's underneath. We should care more about the genotypes than the phenotypes. If we look at this, what does this mean? Well, this means that, in this case, 50% of offspring, 50% will have horns, because horns is dominant, and 50% of offspring here, in this case, will have no horns. So just in case percentages are still a little bit abstract, what that means is, say this mom and this dad here had 4 children, okay? We would expect, on average, 2 of the children to have horns and 2 of the children not to have horns. Now, is that always the case that happens? No, because each time is relatively independent of each other. So it's not going to be a complete, it's like a coin toss, right? The preceding or the following coin tosses do not impact the current coin toss. But you would imagine on average, though, they would work out to about 50% tails, 50% heads. Okay? Now the genotypes, that's what the genetics actually are. So we have 50% that are this kind of heterozygous, and then we've got 50% that are homozygous recessive, like this. Okay? So maybe go through these a couple times. I hope you're taking notes and not just watching passively, going through all of this. The vocabulary is a little bit tricky. You need practice. And there are those 2 questions that are posted to Google Classroom as well. I would strongly suggest that you attempt to do those questions before Wednesday. Okay, attempt, you don't need to finish them. You don't have to turn them in. So in case there's some sort of problem in terminology or how to read them, or you really don't understand what's happening, you can come to class on Wednesday and ask a question. Because if you're having trouble with something, odds are somebody else in the class is also having a similar problem. Okay? You can always email me or send me a personal message. We'll try and solve whatever problems you have. Unless you wait to absolutely the last minute and then ask for help, which then I won't do. You need to show some responsibility and do it beforehand. Okay? Play safe, stay safe. Have a good day.